If we're reading a floor plan for a building, or maybe a side view, which we call an elevation, or if we're reading a map or something, we often come across a scale like this 1 to 100 here. Okay, in this video we'll be talking through how to handle these scales. So most commonly they are written in the form 1 to something, so like the 1 to 100 we just saw. That means if we were to measure any length on the map or on the drawing or whatever, that small version of the real thing, the real life version of that length is going to be a whole 100 times what we measured. Okay, and there's no units there because whatever unit we measure in, it just gets multiplied by 100 and the units get preserved. More on this soon. So it's quite easy to navigate when the scale reads 1 to something, which it almost always is. The easiest way to think about it is to have a measured length on one end and an actual length on the other end. The measured length is something you of course are measuring with a ruler or something. Okay, most importantly, it's on your picture, on your diagram, so the small scale version of the real thing. Whereas the actual length is how long it is in real life, of course. So if the scale is 1 to 100, then to get from the measured length to the actual length, we would be multiplying by 100. And of course, going the other way would be dividing by 100 to go from the real life length back to the one on the picture. So when the scale is written as 1 to something, like our 1 to 100, think of that second number as just telling you what to multiply or divide by to convert from the small length on the diagram to the big length in real life. So let's see an example of that. Say we have a satellite image of a 50-meter long swimming pool here or something, so of course the 50 meters is the longer length in this rectangle. We could be asked to work out the scale, so work out that ratio that tells you how much lengths are being stretched by from the picture to real life. So we'd pull out our ruler, and we'd start by measuring a known length. That is the only way to get a handle on the scale here. Okay, so see how we're using our ruler to measure the length that we know is 50 meters for sure. And just by looking at that, we find that on the map it's 4 centimeters. Okay, so we can write a ratio there with 4 centimeters becoming 50 meters. Now before we continue, there's a problem here, and the problem is that the units don't match up, so it's currently not a fair comparison. So what we might do is change the meters to centimeters. Now each meter contains 100 centimeters, so 50 meters would be 50 times 100, which is 5,000 centimeters. Okay, so now that the units match, we have made a fair comparison, so our scale can be correctly written as 4 to 5,000. Now, of course, it's most convenient to fully simplify this, but also, as we mentioned just before, it's really nice to have the blue number as 1. It just makes the thinking so much easier. So let's divide both numbers by 4, and that gives us the blue 1 we were going for, and on the other side, 5,000 divided by 4 is 1,250. So that's our scale, 1 to 1,250. And what it means is that any length we measure on the diagram must be multiplied by 1,250 to get the real life measurement. Okay, alright, so say now we're asked for the width of the pool. Knowing the scale, we can easily convert a measured length on the picture to the actual real life length. So let's do that. Okay, we'll bring our ruler back, but this time we measure the width that way. And we find it's 2.5 centimeters on our picture. And so we can write that as our blue measured length. Then to convert this to real life, we multiply by 1,250. Okay, if you're ever confused about whether to multiply or divide, just think which one's bigger. Okay, the real life pool is of course bigger than the one in our picture, so we have to multiply by 1,250 to get to the real measurement. That gives us 3,125 centimeters. Note the units haven't changed because again, the scale doesn't mess with units. It compares things fairly and evenly, preserving units. But for practical purposes, maybe we should convert this back to meters so we can divide by 100 to get 31.25 meters, and that would be the width of the pool in real life. So that's how we work with scales on a floor plan or map or satellite image or whatever. Okay, thanks for watching, and we will see you next time.